You feel significant. Of course you do. You are the center of your own experience, the main character of your own story, the one whose hunger matters, whose joy matters, whose losses matter, the one whose life fills the full frame of your awareness from the moment you wake to the moment you sleep. This feeling is real. It is not wrong. But it is also the most parochial, most narrow, most cosmically myopic perspective available to a conscious mind in the known universe, because the universe does not share your assessment of your importance. And the numbers, the actual, verified, peer-reviewed, scientifically established numbers describing the size of the universe relative to the size of you are so extreme, so one-sided, so comprehensively humbling that most people encounter them once and then quietly set them aside. Because truly sitting with them is uncomfortable. Truly sitting with them requires letting go of the instinctive feeling of centrality that evolution built into every brain on this planet. Truly sitting with them means confronting, honestly and without flinching, just how small we are. Not metaphorically small, not poetically small, not the small in the way a person feels small standing at the foot of a mountain or looking at the ocean from a shore. Small in a way that has no adequate metaphor. Small in a way that defies comparison. Small in a way that the human mind genuinely, structurally, neurologically struggles to process. Today, we are going to try anyway. We are going to start here, with you, right now, reading these words, and we are going to zoom out, step by step, scale by scale, until the Earth is a dot, and the Sun is invisible, and the Milky Way is a smear of light, and the observable universe is the only frame large enough to hold the picture. And at every step, we will ask the same question. Where are you in this? The answer, at every step, will be the same. Smaller than you thought. Let us begin with you. You are, on average, somewhere between 1.5 and 1.9 meters tall. Let us call it 1.7 meters. About average, a reasonable starting point. The Earth has a diameter of approximately 12,742 kilometers. That means the Earth is about 7.5 million times taller than you. If you lined up 7.5 million people standing on each other's shoulders, the stack would reach across the diameter of the Earth from one side to the other. 7.5 million people. And that is just the diameter of a single planet, the third rock from a minor star in an unremarkable corner of a mid-sized spiral galaxy. But let us not rush. Let us stay with the Earth for a moment. The Earth's circumference, the distance around it at the equator, is approximately 40,075 kilometers. If you walked continuously at a brisk walking pace, day and night, without rest, it would take you roughly 334 days to walk around the entire planet. Almost a year, just to go around it once. And the Earth is not a large planet, not by the standards of our solar system. Jupiter, the largest planet in our neighborhood, has a diameter of 142,984 kilometers. Jupiter is 11 times wider than Earth. Stack 11 Earths across the face of Jupiter, each Earth containing billions of people, each person 1.7 meters tall, and you would just barely span the diameter of our solar system's largest planet. But Jupiter is not the largest thing in the solar system. The Sun is. The Sun has a diameter of approximately 1.39 million kilometers, about 109 times the diameter of Earth, and about 10 times the diameter of Jupiter. If the Sun were hollow, you could fit approximately 1.3 million Earths inside it. 1.3 million. You, standing on the surface of Earth, are to the Sun what a bacterium is to a beach ball. Smaller. Actually, smaller than that comparison suggests. and the Sun is 150 million kilometers away from Earth. Light, the fastest thing in the universe, takes 8 minutes and 20 seconds to cross that distance. At walking pace, it would take you 3,200 years to walk to the Sun. Not from Earth's surface to the other side of the Sun, just to the Sun. And the Sun is not even the largest star we know of. Scuti, one of the largest known stars, has a radius approximately 1,700 times larger than the Sun. If Scuti replaced our Sun at the center of the solar system, its surface would extend past the orbit of Jupiter. The gas giant that dwarfs our planet would be inside this star. You would be inside this star. A human being standing on what used to be Earth, now engulfed by a star so large that Jupiter orbits within it. And Scuti is one star, in a galaxy containing hundreds of billions of them. We have not yet left the neighborhood.
The nearest star to our Sun is Proxima Centauri. It is approximately 4.24 light-years away. A light-year is the distance light travels in 1 year, roughly 9.46 trillion kilometers. Proxima Centauri is approximately 40 trillion kilometers from Earth. The fastest spacecraft ever launched by humanity was the Parker Solar Probe, which reached speeds of approximately 690,000 kilometers per hour during its close approaches to the Sun. At that speed, the fastest we have ever moved anything, it would take over 6,000 years to reach Proxima Centauri. 6,000 years. The entirety of recorded human history, every civilization, every empire, every war and discovery and invention, from the first writing systems to the present day, spans approximately 5,000 to 6,000 years. A journey of that entire duration at the highest speed ever achieved by human technology would get you to the nearest star, the nearest one. And the Milky Way contains somewhere between 100 billion and 400 billion stars. The Milky Way is approximately 100,000 light-years in diameter. To cross our own galaxy at the speed of our fastest spacecraft would take approximately 1.4 billion years. The universe is 13.8 billion years old. If you had launched a spacecraft at the moment the first simple single-celled life appeared on Earth, roughly 3.5 billion years ago, and pointed it toward the far edge of the Milky Way, it would still not have arrived. It would need another 2.1 billion years. The Milky Way, our home galaxy, the one containing everything we have ever seen with our naked eyes, is so large that it defeats every intuitive attempt to grasp its scale. And the Milky Way is not a large galaxy. Our nearest major galactic neighbor, the Andromeda Galaxy, is approximately 2.5 million light-years away. It contains roughly 1 trillion stars, more than twice the Milky Way's estimated population. 2.5 million light-years. The light we see from Andromeda tonight left that galaxy 2.5 million years ago. When it departed, our ancestors were early hominids walking the African savanna. They had not yet developed language. They had not yet discovered fire. They had not yet made the first tools. That light has been traveling since before we were human. And Andromeda is our neighbor. Our local group of galaxies, the small cluster of about 50 galaxies to which the Milky Way and Andromeda belong, spans approximately 10 million light-years. 10 million! We have not yet left the local neighborhood. Beyond the local group lies the Virgo supercluster, a structure approximately 110 million light-years across, containing over 1,000 galaxies grouped into many smaller clusters and groups. Our local group is a small peripheral member of this vast assembly. But even the Virgo supercluster is not the largest structure we belong to. In 2014, astronomers identified a structure of superclusters, a vast web of galaxies bound together by their mutual gravitational influence, that they named Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea spans approximately 520 million light-years. It contains the mass of 100 million billion suns. And the Milky Way, our home galaxy, containing 300 million stars, orbited by billions of planets, one of which is 12,742 kilometers across, one continent of which is home to 8 billion people, one country of which contains one city, one street of which holds one building, one floor of which holds one room, one chair in which holds one person 1.7 meters tall reading these words. That person is a component of Laniakea, an address within it. Not a central address, not a notable address, one of hundreds of billions of planets in hundreds of billions of solar systems, in hundreds of billions of galaxies scattered across a supercluster 520 million light-years. And Laniakea is one supercluster. The observable universe contains an estimated 2 trillion galaxies. 2 trillion! If you counted one galaxy per second, it would take you 63,000 years to count them all. The observable universe spans approximately 93 billion light-years in diameter. If you placed a scale model of the observable universe in which the entire Milky Way, 100,000 light-years across, was represented by a single grain of sand, the scale model of the observable universe would be roughly 930 meters wide. And in that model, you, a human being 1.7 meters tall, would be represented by a structure approximately 1/10 billion trillionth of the width of a single atom. Not one atom, 1/10 billion trillionth of the width of one atom. There is no object small enough to represent you at that scale. Not a proton, not a quark, not any particle we have yet discovered or theorized. You are, relative to the observable universe, smaller than the smallest thing we know how to measure. And the observable universe, the 93 billion light-year sphere we can see, is not the entire universe. It is merely the part from which light has had time to reach us since the Big Bang. The true extent of the universe beyond what we can observe is unknown. It may be finite, it may be infinite, but it is almost certainly vastly larger than the observable part. Vastly. And somewhere in all of that, in whatever the full universe contains, you are here. One person, one planet, one star, one galaxy, one supercluster, one observable universe. A matryoshka doll of scales, each one dwarfing the last, until the outermost shell is something so large it may be infinite. And you are the innermost doll, the smallest one.
So, you are smaller than a grain of sand relative to a scale model of the observable universe that is not large enough to even begin representing the true extent of the cosmos. What do you do with that? There are two ways to respond to the numbers we have just walked through. The first is to feel crushed by them, diminished. To look at the scale of the universe, 2 trillion galaxies, 93 billion light-years, a true extent that may be infinite, and conclude that you are nothing, that nothing you do matters, that your life and your choices and your loves and your losses are so cosmically irrelevant that meaning itself becomes impossible. This response is understandable. It is human. It surfaces naturally when the scale of the universe is honestly confronted. But it is also wrong, because it confuses size with significance. Size and significance are